Okay, hello everybody. My name is Fdili, Alaoui, and I'm from University Paris Sud. And I'm glad to present my work on behalf of my co-authors on our paper Seeing, Sensing, and Recognizing Laban Movement Qualities. So this work is about the research that we've been doing, exploiting the Laban Movement Analysis framework, where the notion of efforts describes movement expressivity and movement qualities, and the aim is to design for movement-based interaction. So why is this important? This is important because movement is important. From a phenomenological stand, our bodies are who we are. They are our interface into the world. They are how we perceive the world and act into the world. So movement is our signature, and movement is our identity and how we are recognized. But movement is complex, as you can see in this beautiful photography by Edward Muybridge. And as ubiquitous as it has been neglected in science and slightly a bit in HCI. So in HCI, when we talk about movement, we most of the time talk about a limited range of gestures and actions, such as swiping, touch gestures, etc. And although third wave HCI have been advocating for integrating expressivity and affect and expression in interaction, movement remained mostly understood as a functional component of interaction. But as we all know, because we all experience it every day and every second of a day, movement is much more than that. And I'm particularly sensitive to this topic because I'm myself a dance practitioner and a Laban Movement Analyst, and I think that movement has a lot to offer to the HCI community. My work intersects dance and dance theory to HCI to integrate a larger range of movement expressivity through the notion of movement qualities. So let's see how in dance, for example, through the beautiful words of Pina Bausch, we manipulate and talk about movement qualities.
I'm standing on the spot and actually suddenly it's like I move. I go very down, suddenly I go very up, but I'm standing still. This is very nice, I think, this moment. It's like I'm flying there, or I'm in the water, I'm there too.
So as you can see, in dance, movement qualities are a material that we manipulate and that is very central to our practice. Let's define a little bit what is this notion. Movement qualities are the distinguishable, observable, qualitative attributes to movement that are not necessarily related to the action or the trajectory, but can be related to the force or the dynamic of a certain movement. And in this work, we look at movement quality from the lens of the Laban Movement Analysis. This lens is particularly interesting because it allows us to describe and observe movement through four main categories: body, effort, space, and shape. Body is what is moving, a body part, for example. Effort is how the movement is occurring, and that's the notion of movement quality. Space is where the movement happens, and shape is how the body changes shapes in time and space. So when we look at efforts in particular, Rudolf Laban has delineated this category in four discrete factors: weight, time, space, and flow. Each of these factors is thought of as a continuum with two opposite ends called elements, in which movement can vary and thus reveal different movement qualities or effort qualities. So space is related to the attention to the surrounding environment. One can span the totality of the environment in indirect space or focus on one singular point in direct space. Time is related to the quality of acceleration or the quality of deceleration in sustainment, so quick and sustained. And effort is related to how one exerts force in strong effort or a delicate intention in lightweight. And finally, flow is related to the quality of release in free flow and control in bound flow. In reality, these effort factors are usually expressed in combination. They're rarely observed in isolation. So here are two examples of combining weight, time, and space effort in what Laban called the basic effort actions. So in the picture on the top, you can see a floating effort actions with light weight, sustained time, and indirect space versus a punch where we have a strong weight and a direct space effort and a very quick time effort. There are actually 8 of these basic effort actions in the 8 possible combinations of the effort factors of weight, time, and space. And in this case, flow is neutral, so it's not emphasized. And these are the focus of this paper. We are interested in them because they are very well defined and very well articulated, and they are observable in reality in many actions that we can take on. We are not the only one who have been interested in the basic effort actions. There is a rich literature around them and around modeling these effort actions. For example, work by Kamuri and his lab on the oise web platform using video data to model these effort actions, or work by Helena Mentis and Caroline Johansson on detecting effort with the Kinect data. As well as lately the work by Maranan et al. With the effort detect system that uses a single accelerometer to characterize these efforts. From our literature review, what we've been able to see is that there is a big heterogeneity of approaches to these effort actions, and this is due to multiple things. First, these notions are complex because movement is complex and because us as human beings are complex. But also because there is somehow a lack of movement and Laban movement literacy in the HCI community. It's a framework that is really hard to master and that is quite complex to understand. So to address this issue, we argues for integrated Laban experts in modeling the effort qualities. Because we're aware that movement expertise is critical in observing and describing movements, we run an interview with Laban experts to unpack their observational process of these Laban efforts. And from that, we started making our computational system very much inspired by their observational process. So we interviewed 2 certified Laban movement analysts, and the specificity of these 2 experts is that they're super experts. They train Laban movement analyst students and direct the Laban training all over the world, and they have collaborated with each other in the most impactful observational projects involving, for example, making movement portraits of politicians on TV and so on. So we invited them and interviewed them and asked them to watch a video with these 8 effort actions and asked them to talk out loud about describing what they saw and how they observed it. And what we learned from this interview is that, first of all, in most cases, a multitude of things happen. There's very rare occurrence with one aspect of these efforts happens alone. So the complexity is additional. And another thing that we learned is that these experts rarely observe or prefer to observe in groups because observing in groups allow them to achieve an agreement and to make a decision that is more reliable about what they observe and how they observed it. On the other hand, what we learned about in this interview is that their observational process is multimodal. So they don't only use their eyes to see what's going on, they use their kinesthetic empathy, the visual and the sonic cues, and other elements to understand what's going on. So for example, for weight efforts, one of the CMAs said, the mover can also experience weight through the muscular response toward gravity. So here we saw that the muscular force is critical in understanding weight effort. For time efforts, they observe it through the pattern of change in movement acceleration and deceleration. So acceleration is critical. And for space effort, one of the CMAs said, the CMAs are picking up kinesthetically something about the movers accessing a sensory gathering that their entire body sees with the back surface of the body. And while discussing with them, we realized that the space effort is actually extremely difficult to see from video data. So through discussion, we came up to agree that the opening of the chest and the upper body is an interesting cue to understand these effort qualities. We integrated the results of our interview to design a computational system that is composed of multimodal sensors that directly correlate with how they observe these efforts, efforts features for each of the multimodal data, and the machine learning algorithm that allows to recognize in real time those basic effort actions and effort factors alone. So, for example, for time effort, we selected an accelerometer that allows us to collect inertial data and computed the dynamic feature of the norm of the jerk to characterize the progression of the acceleration and deceleration. For weight effort, we used an EMG for physiological measures and computed a feature related to muscle activation. And for space effort, we used a Vicon motion capture system that allows us to capture positional data and compute a feature related to the space between the elbow and the chest that allow us to gather the opening of the chest and the upper body. We then used the machine learning method based on hidden Markov models and fed it with the effort features and of weight, time, and space, and all the three combined. Our intention in using this model is to have a model that is suitable for movement-based interaction. We chose a method that allows for real-time recognition of effort qualities because HMMs are a machine learning algorithm that continuously estimates the likeliest efforts, or BEAs, basic effort action, at each time step. So we evaluated our features performance for a task of real-time effort recognition using the machine learning algorithm. And for that, we invited two Laban experts again and asked them to perform different movement phrases, some that are composed of these basic effort actions assigned in space, and others that are composed of these basic effort actions disassigned in space and in different orders. And the measure here is the quality of the recognition as the percentage of the frames that is accurately recognized by the algorithm. So let me show you a video about the type of data that we collected with EMGs, accelerometers, and Vicon motion capture.
EA is 1. Karen, EA is 1. Action.
So this is a float, and a punch, and a glide, slash, dab, ring, and flip, and press. So as you can see, these effort qualities are quite distinguishable by a human being. They're very, very, very different from one another. The question now is an algorithm or machine learning algorithm able to distinguish them? So we compared these features recognition rates for the basic effort actions and for each effort factor alone. And here what we saw is that our dynamic feature significantly better recognizes the effort factor of time, just like we designed it, and the physiological feature significantly better recognizes the effort factor of weight, as you can see it in yellow. For the space effort, we didn't have a significant result, and that relates to the difficulty of capturing these attentional quality of indirectness and directness. For the basic effort actions, as a combination of the three efforts together, what we saw is that the combination of the multimodal features altogether gave the best results and significantly. So what we learned from this experiment, or these results, is that, first of all, the multimodality is key here. We cannot really address efforts, actions, or effort qualities by using one single accelerometer or one single camera, etc. Multimodality allows for a richness that allows to capture the richness of these qualities. And the other thing is, probably for future works, about space efforts, that is still a challenging aspect of what HCI can capture so far, because it's related to our attentional qualities. So this computational system, as it was intended, have been used in different contexts that are related to dance. Here, a pedagogical context where we're learning, where we're teaching people these effort qualities through sonification and real-time sonification of their effort qualities. So the dancer is wearing an EMG and an accelerometer, and her efforts are recognized in real time and sonified to give her feedback. Okay, other types of applications. I'm right now working on a piece where I'm using this machine learning algorithm with dancers. This was a workshop that we ran a few months ago, where a dancer has been training the system and trying it out, improvising with what the movement vocabulary that she trained, and seeing how the system is reacting to her improvisation. So the contribution of this work, first on an experimental level and on a computational level, we propose a set of multimodal sensors and a set of multimodal features that correlate with what experts have told us about observing efforts, and a machine learning algorithm to evaluate these multimodal features. But on a methodological level, this work allowed us to emphasize the value of expertise and movement knowledge to actually model these effort qualities for HCI and interaction design. So we believe that this work has potential for movement-based interaction, any movement-based interaction that is interested in integrating expressivity and movement expression in general, with applications in the arts and entertainment or other applications, actually. So I'd like to leave you with a little sentence that I find extremely interesting about the importance of such work, or the importance of movement, because, which is connected with the mastery of movement, remains fundamental as long as the human race exists. And that is by Rudolf Laban. Thank you very much, and I'm happy to take questions.
Hi, thank you. I enjoyed seeing the human movement, and I'm really fascinated in this movement digital interface. Did you find that actually? Oh no, I won't tell the story. Did you find that the dancers did their movements change when they were being recognized by a system? Were they looking to see whether their movement was recognized or not? And if it wasn't recognized, did it shift what they did? What sort of interaction is going on there?
Yeah, there is definitely an effect of the technology and how they behave and how they, on their rhythm and how they improvise, etc. So the thing is that the technology doesn't work as well as an eye of a choreographer. So it's buggy, and sometimes it might recognize something that is not necessarily what they're intending, especially when we go into much more complex realm in dance. However, it allows them to really reflect on what they're doing and start to really improvise with the machine and say, well, now it's recognizing it, now it may be not recognizing it. Maybe I've done something that made the machine not work at this point, etc. So it's a good feedback for training, and it's a good feedback also for reflection.
Hi, really nice to see the work. I noticed that the Laban expert that you had all suited up when she was making the movements was vocalizing them.
Yes.
And that was very evocative. And interestingly, you sonified in the later. So sound actually seems to be an important element, both as input and output. Yes. And so I wonder if that could have been a capture modality that you could add.
Yes, audio. A very good question. Actually, we've published a paper at Designing an Interactive System in 2012 that is somehow related to the same algorithm, where the sonification is used as for the synthesis. And that's what we use in the workshop with the dancers where they're learning the effort qualities. When they are performing one of the effort qualities or one of the basic effort action, what they hear is the sonification of Karen playing or performing these efforts. So sonification was a good way to actually give them feedback as an output of these efforts. On the other hand, when you learn how to perform these efforts, most of the time you use sonification to understand or to even reflect on how you're doing it yourself. So vocalization is really critical in learning how to integrate these effort quality. But we definitely used it at least as an output for the dancers. Now for input, maybe that's a good future work, or maybe we can try that out. Yeah, thanks.
Hi, Andrew at Kern, Texas A&M. It's really interesting and beautiful work.
Thank you.
Yeah. So I was curious, you mentioned in passing the idea of segmenting, and that seems both epistemologically and technically really interesting and challenging, and I was just wondering what your thoughts are about that as a process and its role in the work going forward.
Do you mean by that segmenting the movement phrases? Like
that's what I thought you meant when you...
Yes.
I saw it was a word that was in one of your slides, and that's what I thought you meant.
Yeah, what happened is that when we collected the data, the performers performed the 8 basic effort actions one after the other. And what we had to do was to segment them manually in order to train the system on each of the basic effort action alone. And that is a very difficult question, even when you're doing it manually, because the end of a basic effort action might be the beginning of another one, etc. So you might need to make a decision about where a phrase starts and where a phrase ends, and that might affect your recognition rate sometimes. So we've been doing that iteratively until a moment where we thought it was a satisfying set of segments that we would feed to the machine. And I don't know any of another way to do it than empirically by hand, basically.
I encourage you to think about segmenting, and it's like a seam. And
it's a difficult question.
It's really interesting. And
it's definitely interesting, and it's a difficult question for sure. Thanks.